Welcome to the AMATIC 2017 webinar series. Today we have a special treat. We are looking at incorporating discovery into developmental mathematics with George Woodbury. This presentation is sponsored by the Developmental Mathematics and Innovative Teaching Learning Committees. Please note that the views expressed by the presenter are not necessarily the views of AMATIC. Commercial products mentioned by the presenters are not endorsed by AMATIC. McGraw-Hill is our sponsor for our webinar series. Thank you very much, McGraw-Hill. George is actually going to introduce himself, and so without further ado, I'm going to go ahead and turn it right over to him.
Hey everybody, this is George Woodbury. I teach at College of the Sequoias in Visalia, California, right in the heart of the Great Central Valley, about 40 minutes south of Fresno. And when I was approached to do this, I'm a big AMATIC supporter, our local affiliate as well. I've been going to AMATIC since we were back in Phoenix, and I've learned so much from my AMATIC connections that having a chance to sort of share with you here is really rewarding to me. So thanks everybody for participating, and I hope that over the next hour you pick up some things that you can use in your classroom as early as tomorrow. So let me share my slides with you. Here we go. So the title is Incorporating Discovery in Developmental Mathematics. My email address is shown at the bottom of the screen, and there will be some contact information at the end as well if you need to get a hold of me. So a little bit about my classroom style, my learning style. I use the cycle of learning that's shown on the screen, and it's a three-part cycle. I try to get my students to discover as much as they can on their own, then we'll engage together, and then finally we complete the cycle by reflecting on what we've done. And I think that in these three areas, we've done a great job as a group in terms of the middle piece, engaging with our students, getting our students engaged with the mathematics. But where I think that we can still do some improving is at the beginning and the end of this loop, on discovery and reflecting. A little bit about reflecting before we jump into discovery. I don't think that any learning experience can be complete without reflecting back upon what we've done. What have we learned? How is it different than what we've seen before? How is it similar? Where could this be leading us to? And maybe in a future talk we can discuss that. But I'm going to focus on discovery in the classroom. So the first question that you may have is, can developmental math students really discover this material? Are your students in elementary algebra, intermediate algebra going to be able to discover this material, how to solve certain problems, etc.? And what I want to say is that I'm not really looking for my students to discover everything independently. I want my students, though, to participate in the discovery. So you can think of it as sort of a guided discovery, if you will. As I teach, my job, I view it as trying to lead the discovery without really dictating to the students what's going to be happening. And I'll explain that as we go. My goal, as it has been from day one, is to get my students involved and engaged with the material. My classroom, I try to run it more in a collaborative style, so my students are always volunteering, talking, explaining, and I feel more as if we're having a conversation than they're being talked to. Finally, the last thing I'm trying to do is help my students develop that little voice that when they're working on their exam, that little voice that'll pop into their head about what their colleague said or what I said or what they were thinking when they explained this problem. So I'm trying to help them to develop that little voice, and that's all part of this discovery process. So here's an example from this semester. We could have picked one of a million different ways to do this, but here's a pretty typical first example from solving absolute value equations. And as I see it, we have two options in terms of how to proceed. First, we can clearly explain the steps for solving this new type of equation. So, we could tell our students, isolate the absolute value, and then you want to rewrite that as two equations. And even though we may be explaining why, we're still telling them that they have to rewrite it as two equations. And then finally, we tell them to solve the equations, and they'll have their two solutions. But there is a second route that we can go. And what I did was I asked my students, can anyone find a solution of this new type of equation? I didn't mention what kind of equation it was. I didn't give them any directions for what to do. I just put the equation on the screen and said, can anyone find a solution? And the real trick here is that you have to be willing to wait for students to come up with a solution. The 10 seconds it takes them to process even what you're asking them, added on to the 20 or 30 seconds that they have to think about it, can seem like an infinite amount of time. I've often joked where if I'm going to be told I have an hour left to live, I want to spend it inside a math class, because that time that you're waiting can seem like it goes on forever. So if that happens, that's where I want to be. So you wait and you wait for your students to come up with a solution, and someone will finally come up with a solution like 19. And then I have a chance to say, well, how did you come up with that? And typically what you'll hear at that point is a student will say, well, I thought about what I would do if those absolute values weren't there. I would add the 5 to the other side, and now I've got x minus 6 equals 13. And so I'm thinking about what number minus 6 will give me 13, and I come up with 19. And once the student articulates that approach, then another student will be able to pick up and say, well, if that's how you got to 19, if the absolute value is equal to 13, that means what's inside could be 13 or negative 13, and they'll lead the way towards the second solution. The real trick is not to come out and volunteer it yourself. It's to give them time to try to come up with an approach on their own. Then we can talk about, here are the steps for solving this. Here's the reasoning behind it all. But if they discover this on their own, they take more ownership of the learning process. And if there's one thing that I've learned, is that when students are in control or sense some sense of control, it's more fun for them, and they're more likely to persevere than if they feel that math is just something that's happening to them. We learn about mindset and this idea where students get into this mindset of feeling like a victim. Here, we're giving them some responsibility, and we're encouraging them to think rather than just follow some random directions. So summing that part up, the goal here is to get students to think, to get them to be engaged and active, and not be a passive victim in the process. And finally, the more we can get them to explain their reasoning and share their strategies, the better their learning will be, but also the better their colleagues' learning will be. I learned to solve that type of equation 30 years ago, and I don't remember exactly what it was that lit the spark for me to help me understand what I should be doing. But that student that's sitting next to you that just figured out how to do it on their own, they can explain it much better in a way that you can take it and learn from it. So I'm trying to get my students to explain what they're doing and share what they're doing as much as possible. We're going to go over 4 strategies today, and the first strategy is one that you can use in your classroom tomorrow. I call it the reversal. Let's set the setting here. I'm in an elementary algebra class. We're getting ready to learn how to factor trinomials with a leading coefficient of 1. And so I think a lot of us probably begin with a warm-up. I put 4 problems on the board. I ask them to multiply them out. Give them a couple of minutes. They multiply them out. And then I say, I've got one more problem here, but I'm having a hard time reading my writing. All I can tell for sure is this is my answer. Can you tell me what I would have multiplied to get to that answer? And I'm going to back it up a slide. When we show this in class, that's usually the beginning of the lecture where we start to point out, are there any patterns that you see here? Notice that 8 and 5 can make 13 in one way, but they can make 40 in a different way. and we see 6 and 9 turning into 15 and 54, and so we start to develop the pattern for them. But the way I've presented it here, the student has to look at what they have to see if they can find their way to it. And they can pick up on those patterns on their own. Once they do that, and a student will tell me, I have x plus 6 times x plus 9, then I can say, congratulations, you've just factored your first trinomial without being told how to do it. Then we can start the discussion of factoring trinomials. Another example, after I cover how to multiply a monomial by a polynomial, there are several types of questions that I can ask, starting with this one. I'm giving you the monomial. Can you tell me what trinomial to multiply this by to give me the trinomial on the right-hand side? Or I can leave off the first part. This is leading into the idea of division by a monomial. It's also leading to the idea of factoring out a GCF. That leads to this question where now I don't give them either, and I ask, can you give me 2 expressions to put where the question marks are so that their product will equal the trinomial shown? Now students have understood the concept of factoring out a common factor without me telling them how to do that. Now, I'm not saying that that's where we end it. I'm saying that that's the launching point. Now that they've thought about it and truly thought about it, now we can use that to build some conceptual understanding of what is a GCF, how do we find the polynomial factor, etc. Let's take a look at another one. If you've covered how to graph square root functions, we can reverse that up. Instead of going from a function to a graph, how about from the graph back to the function? That's going to solidify their knowledge of how to graph one of these functions without me telling them how to work your way backwards from a graph to a function. Can you figure this out on your own? Let's look at another one. After you cover solving quadratic equations by factoring, a great idea is to provide your students a solution set like I did at the beginning. Here's the answer. What's the question? What's the equation that leads to the solution set? And see if they can find their way back to that equation. Once students understand things pretty well in both directions, you know that they've built a foundation that can be built upon safely. The next one, it appears it's your turn. So I'm going to give you a couple of moments to think about a way that you can incorporate this into a class that you're teaching right now. Go ahead and think about it for a moment or two, and then type a concept that you think fits with this reversal process in one of your classes into the Q&A bar.
So just know that your responses, we're going to read them, but your name is not recorded. Like it's not. This is not documented forever what you said. So feel free to add something in there. So George, one of the participants today wrote down properties of exponents as one of these.
When I gave this talk in AMATIC, that was actually the first one that came up.
Okay.
Was the idea of using properties. I think it's a great place to begin, right? Working your way backwards from a solution to the problem that led to it. And I think that that's a great choice, yeah.
Okay. Another participant said translating graphs.
Have you been reading my script? We're going to be talking about that a little bit later, but that's also a really good place to do this, for sure.
Okay. Another one that came in was percent change.
Oh, I hadn't thought of that. That's actually really good too. Percent change. I'd like that.
Okay. We got one more. It's inequalities.
So inequalities, working backwards from, say, like a solution or a graph to the inequality that led to it, that's a really good place for it too. You know, in just a couple of minutes, right, we've come up with a handful of ideas. You can do this every day in every topic pretty easily, and it's a great way to get your students to think. Are there any more that you want to mention, Julie?
There, 3 more just came rolling in. Partial fraction decomposition.
Ooh.
I know. That's what I thought too. Absolute value inequalities. And then
Perfect.
solving higher degree equations using factoring.
Perfect. The absolute value inequalities is a really good one too. And that's one of the most interesting topics because every day I gave that lecture, I thought I had given the greatest mathematics lecture ever. And then when you look at their work on their exams, you feel like you were speaking underwater. I mean, it's a very tricky topic for students when they're not thinking about it. You know, a lot of the students that we get in developmental math are students that have been trained to learn one way, and that's using some sort of a mimicking approach, and they're just trying to duplicate what they see without really thinking about what it all means. And if you can get your students to think about those absolute value inequalities and equations, they're going to remember that much better. They're going to understand what they're doing instead of just trying to, you know, duplicate some steps. So I think that's a great idea. And the partial fractions, I think students could really use some understanding there for sure. All right, I'm going to go ahead and move to the next strategy. And this is what I call my Wolfram Alpha style problem. I'm not sure if we're all familiar with Wolfram Alpha, but it's explained as a mathematical search engine, but it's really a pretty powerful computer algebra system that's available online or in a smartphone app. And what it does is if you type a problem, it'll give you the answer. And, you know, under the right conditions, it can give you the steps to get that answer as well. But I'm going to incorporate the problem and answer part into this second strategy. So I walk in on the first day of rational expressions, and I put this problem on the board, and then I usually say something like, wow, that was a lot of writing. My arm is tired. I don't feel like doing this one. So here's what I'm going to do. Here's the answer, and I want you to tell me how I get from the problem to the answer. So students have to start to think about, you know, how do I make my way from a problem like that to this answer? The fraction at the bottom looks simpler. How do I get from there to there? And they start to think about, well, what have we done recently? And we've just finished up the chapter on factoring. Well, maybe we should factor something. And then somebody will factor that, realize that there are common factors in the numerator and the denominator that they can divide out, and we produce that answer. And then I can say, congratulations, you just figured out how to simplify a rational expression. We can talk about how it's similar to working with fractions involving constants. You know, how do we reduce a fraction to lowest terms, simplify a fraction to lowest terms, and how it's similar. Also, again, it gives you a chance to reinforce how important factoring was from what we had just learned in the last chapter. And students realize that they didn't have to be told. You know, I could put that problem on the board and say, here are the steps. 1, completely factor the numerator. 2, completely factor the denominator. 3, look for factors that are common and divide them out. But it's much more meaningful if students can come up with this on their own. Here's another example of a Wolfram Alpha style problem. After I've done that one, I move right into multiplication. And I put the problem up and the answer, and can you figure it out? And they actually are a lot quicker here. They figure they can use the same kind of strategy, and they do. You know, it takes a little longer to factor 4 trinomials or 4 polynomials instead of 2, but they know what to do a lot quicker, and you can congratulate them. You just figured out how to multiply rational expressions. And then the same day, I follow up with a division problem, and they have to try to think about, how is this different? What can I do? I'll factor, but that doesn't seem to give me the answer. And then somebody will remember from arithmetic, oh, we're supposed to flip a fraction at some point, and they'll start to discuss that with each other. And it's really a great way for them to take ownership over that process instead of just me telling them. Now, again, I can fill in the ideas, the concepts behind it, maybe give them some tips on how I see it. But if it's coming from them, I think it's more powerful. Here's another example. This is from a previous chapter, dividing a polynomial again by a monomial. Give them the problem, give them the answer. Can you figure out how to get from A to B? And they can do a pretty good job with that. Then they can tell you, when I want to divide a polynomial by a monomial, I just think of it as 3 separate fractions here and reduce each one. And that's good enough. Now, again, here we come to a spot where you can share a type of problem that you think would work here. So in the Q&A box, if you can type a type of problem that you think would work well with this question and answer you fill in the middle format, go ahead and type that in now.
Okay, we already have one idea in it, and it says, I used this yesterday with order of operations, which is pretty cool.
That's a good one. Depending on how complicated it is, you have to kind of pick your spots in terms of, you want to pick a problem that's challenging, but also accessible to a decent number of students in your class where they can make their way from A to B. But I think an order of operations is a great place to do that.
Mm-hmm. That was a great segue for a question that came into the box a while ago, and that was actually with the last technique, and it was, how do you avoid a situation where the advanced students are the ones engaging in the dialogue with the instructor, with the rest of the class remaining passive, just like in a traditional lecture classroom?
Yeah, it's always challenging, right? And so I'm a little more subtle with my students in terms of can somebody else, is there someone else that can explain how to do this one? And I'll have a discussion with those students about why we're doing it this way, so that they understand that by hearing other viewpoints, it's going to help the entire class. Sometimes students feel like they have to prove that they understand, and they're very excited about the math and they want to get involved. But I think my feeling with students is that if you explain to them why you're using the strategy you're using, that it's a lot easier to get them on board with waiting and giving other students a chance. But it is pretty challenging sometimes.
Definitely. So we don't have any more ideas from George's. His original question was trying to look at different kinds of problems that you could use with this Wolfram Alpha technique, where you give the question and give the answer. Like derivatives and the beginning of chain rule came to my mind right away. I'm kind of surprised no one wrote that down.
Yeah, that's pretty good. I mean, and it's, the main area here is developmental math, but it's a strategy that can be used across the board. And, whether you're talking about your stat class, calculus, college algebra, there are places for this to show up as well.
Mm-hmm. We just had another response in the Q&A box, and it was, my students had to develop the equation y is equal to a times b to the x to find a and b using a similar strategy.
That's pretty good too. I'd like that. So maybe I could get a little follow-up on that. So would you give them data points to use there?
I'm assuming, but I don't know because they didn't write that in there. Maybe that person will pop something else in the Q&A box for me. We had another one that was, oh yes, they get data points, definitely. Okay.
Yeah.
We have another one in here that says problem statement and colon. A solution of orange soda and water is 1 orange to 4/3 soda. And then they give the answer that it's about 57% soda. So filling in those blanks again, that's pretty cool.
That's really good.
You got another one that says the question is, what's the discounted price of a $200 jacket after a 30% discount, and they give the answer.
Yeah, I think that's really good. And it also gives you a chance to talk about answers that make sense if you're talking about an applied problem versus answers that don't. If this $200 jacket is going to be discounted, we're expecting the price to be lower. And so suppose it was this price. I like that. Very good.
Right.
All right. I guess I can move on. You can continue to enter if ideas pop into your head as we go. I think that would be great. I'm going to move on to the third strategy, which is using technology to develop graphing strategies. And we're actually going to begin with a poll here.
Okay, so you're going to see the poll launch up here. I'm going to go ahead and launch it. So you're going to describe your experience with Desmos, whichever one best fits you. You've never used it. You've used it yourself, but not with students, or you incorporate it in your classes. Okay, almost all of you have voted. I'll give you another 3-4 seconds. You just have to commit. Again, no names. I'm not gonna record who does what. Okay, so somebody actually sent a question that what is Desmos, which I'm sure you'll answer, but you've got 54% that say that they have never used Desmos. You've got 19% of your audience has used it themselves, but not with students. And then you've got 27% that are incorporating it in their classes.
Awesome. Well, this could be a really big day for that 54%. Desmos is an online graphing calculator. It does a few other things too. They're continuing to develop it into a teacher-friendly format, and they've just opened a geometry-based version of it. But it's a free website, desmos.com, and they also make an app for iOS and Android devices that allows students to type in an equation or a table of values and graph it quickly. It also helps to find just for important points like intercepts and so on. And you can even use it to help show translations of graphs. And so we'll be talking about all of those in these next couple of slides. But I just think it's a fantastic program. And we may be a little nervous about handing our students that technology, but I think the level of understanding that they can gain from it is really big. So I'll show you a couple of different pages that I've made with Desmos that I've used with my students, and maybe I'll show you a little typing that you can do as well to show how it all works. All right, there we go. So this first one is about properties of graphs and graphing parabolas. On the day that I'm going to teach my intermediate algebra students how to graph a parabola, or we're going to discuss it together, is probably better said, they've never graphed a parabola or anything like it. And so if I put the equation up, they have no idea how to discover where to go. I mean, they might make a T-bar chart of X and Y coordinates, but it's still going to be hard for them to know exactly which values of X to use and so on. So I'm going to go ahead and switch over to the Desmos graph. I just actually graphed one and asked them for their interpretation. So let me share that with you. Okay, so here's the one of the pages on desmos.com. In the equation box, I just typed y equals x squared minus 6x plus 8 and asked it to graph it. And so I have my students look at it, and I say, okay, if we're going to graph this, what do you see? And they'll talk about how it's bendy or curved rather than straight. And I say, if you were going to teach somebody how to graph this, which points do you think are important? And someone will say, well, the point where it crosses the y-axis is important, the y-intercept. And so we'll ask, do we know how to find a y-intercept? And they do from before. And other students will talk about the x-intercepts, and we know how to find those from before. And some student will say, well, that point there at the bottom is going to be pretty important, where it turns around from going down to up. And it gives me a chance to say, well, that's the vertex, and we're going to learn how to find it. But I think that it's more powerful when they figure out which points are important than me saying, okay, here's how you graph a parabola. Step 1, find the vertex, and here's the formula for the vertex. Step 2, find the y-intercept, and here's how you do that. Step 3, if it has x-intercepts, this is how you would find them. And then, talk about the axis of symmetry and so on. This just gives them a great chance to develop that on their own, feel a little more ownership. And when that happens, I think that's where they're open to learning more. So every time I do a graph a new function from a new family, this is where we begin. and I ask my students, what do you think about this function? How is this different than what we've seen before? What points do you think are important? Can we develop a strategy for finding them? The second Desmos, sorry, click on the right thing. The second Desmos screen that we're going to go to involves translation. So that was one of the questions from before about translating a graph using H and K. So this one is valuable not just in a developmental sense, but if we're talking about trigonometry, this idea of translations is really powerful, and using Desmos to do it is pretty easy. So let me show you that page next. On the screen, I have the graph of an absolute value function, and I typed it in the bar as y equals absolute value of x minus h added to k. And I created two sliders for h and for k. And that allows me to look at what each value does to the graph. So if I grab the slider and I slide it to the right or to the left, we see what happens to the graph. So I get to a point over here like h equals 5. So now I've got the absolute value of x minus 5. Notice that the graph shifted 5 to the right. And then I can grab the slider for k, and maybe I move that down to -4. And my students see that that value of k actually moves the graph 4 in the negative y direction, down by 4 units. And so it's a pretty good way to investigate how different parameters are going to affect the equation. So is it difficult to make? It's not. It's really easy to make one of these graphs. I'm going to hide the graph, and I'm going to just type in a trig equation and show you how easy it is to make one of these. So let's just say something like y equals a times sine of bx, and maybe on the outside plus c, something like that. As I type that, everything that wasn't a mathematical function, it asks if I want to create a slider, and I can create a slider for all of them or just one or two of them. But now it gives me a chance that now that graph's on the screen in front of them. Now we can see what does changing A do to this graph. How about changing B, and so on. It's really easy to get your students to type this in and develop it on their own. And if your students are like my students, there are a lot of them that have a smartphone that can grab this app and put it on their phone, and they're right there with you. My favorite Desmos activity was the parabola one. On the day I was going to introduce that in class, our projector was broken. And so my thought was to bring up everybody and have them stand right around the monitor so we could look at what was happening. And they're like, Woodbury, no, 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 no. We've all got that on our phone. We'll just type it in on our phone. And it was perfect. So it's pretty powerful. It's very mobile. It's easy to use both for you and your students. And there are a lot more features for using it in class. They have like a PowerPoint style teacher set of slides that you can use to walk your students through a lecture or discovery if you want to. So Desmos.com is the name of the site, and I'd encourage you to give it a whirl. It's really powerful, and it's very forgiving in the way you type too. For instance, if I didn't type y equals, it would still know to graph it. But I can also graph things that aren't solved for y, like x squared plus y squared equals 9. It'll graph right away. So if you haven't used it before, I definitely recommend trying it out. Okay, back to the slides. And the next and final strategy that we're going to talk about is flipping the classroom. So we're going to follow up with one more poll question here.
Okay, I'm just switching. Sorry.
Mhm.
I'm going to go ahead and launch it for you. So you want to describe your experience with the flipped classroom. So the first choice is never used it. Second choice is have used it in a targeted fashion focusing on particular topics. Or I regularly flip my classroom. So you guys are voting faster on this one. Maybe because you know what to expect now. We've got almost everybody voted. I'm just going to give you another few seconds. Okay, it looks like everybody who's going to vote voted. I'm going to go ahead and share those results with you. So we're looking at 38% have never used it, 41 have used it in a targeted fashion, which is your highest one, and then 21% of your attendees today are already flipping their classroom.
Excellent. So this strategy, flipping the classroom, the idea is that we're trying to move some of the discovery, some of the learning outside of the classroom in an effort to make the classroom session more engaging, more active, where students are really participating. And so when we first started talking about the flipped classroom, I feel I want to be really progressive as an instructor, but I feel that I drift back to being more traditional as my default position. And I started as B myself, trying to use it in a targeted fashion. I tried to find topics that I wish I just had a little more time with. And I tried to farm some of the learning out to the students before the class began so that I could use that extra time on the material that I felt was a little more difficult. And I had great results with it. And I've drifted from B to C now. My classes are pretty much all flipped classrooms now. And it does sort of change the way you teach. I feel that the adjective for me now is agile. I want to be an agile teacher, and you never really know how the day is going to go. You know, what did they understand really well from the night before? Where do they need more help? Which problems in the problem-solving session are going to give them trouble? Which ones are going to be easier than you expected? You know, you have to be ready to go, and it's a lot more fun to me that way because I never know what to expect. But the last strategy that we're going to talk about here really focuses on some ways to do it in a targeted fashion first. And I'm going to begin with a flipping the classroom activity that I did for simplifying radical expression. So my students had, at this point in the semester, had already learned how to find square roots and nth roots that worked out cleanly, where there was nothing left inside the radical. And so the next class section, we were going to simplify ones where they didn't come out cleanly and then transition to adding and subtracting radical expressions, which, you know, is a little more difficult. I wanted to spend a little more time there, but I wanted my students to come back ready to simplify really any radical expression that they were given. What comes out, what stays in. And so what I did was I created a video on YouTube. I'm going to share that with you now to show you how this goes. Oops. Share the sound so that you can hear it. And I'll start it.
Hi, this is George Woodbury from College of the Sequoias in Visalia, California. And in this short video, I'm going to go over how to simplify radical expressions. I'm going to begin with an example. We want to simplify.
So I'll pause it there for a second. I walked them through a few examples where they're simplifying radical expressions containing variables. So here is one of the couple of explanations I gave for how to work through this one. And then there were more examples involving variables. So students walk through these, and I encourage them to try the problem first and then play the video to see the solution after they had seen the first couple. Then we moved on.
5 is 5 numbers. So this answer is close to 5, but it's not exactly 5. When we're taking a root of a number that we don't know the exact square root of, the first thing we want.
So I walked them through a strategy for how to simplify the square root of 24, and then we move on to 3 examples that they would work through on their own. So by the time this is done, they've simplified 6 radical expressions so that when we come back to class tomorrow, I don't have to spend very much time. I can incorporate that directly into the addition problem. So I could pivot into the square root of 28 plus 5 times the square root of 63. And we could quickly simplify them and then start to talk about the idea of like radicals, how to combine them, and so on. And what I figure I saved was about 15 minutes in class. That gave me 15 more minutes for a little more discovery with the addition and subtraction, and also that conversation that means so much to us inside the classroom. So one idea that a lot of people have about the flipped classroom is that it all has to be video based. And although video is the style of preference for a lot of people, it's not the only way you can do this. It has become more accessible to do it this way with YouTube, and there are a lot of videos that are available by other people. You don't have to make your own. You can use other videos in your flip, but we can also use publisher videos. There are a lot of different places that are out there that we can grab that material, so that makes it easy. It doesn't have to be video though. And so let me show you a second flip that I did, this one involving graphing absolute value functions. So on the screen now, this is a worksheet that my students took home with them. And the first thing they did was they completed a table of values for the absolute value function, absolute value of x minus 4 plus 3. And so I gave them the values of x to substitute. They worked them out here, and they wrote their ordered pairs. Then they plotted those points on the graph, drew the V-shaped curve that went through them. So some direction for them to work on this, but they're discovering it on their own. Then on the second page, there was a second one where, again, I gave them the values of x that I wanted them to use, chosen carefully to be centered around the V point of that graph. And then finally, there was a third question where they weren't given any values to work with. So they had to figure out which values they were going to use. And when they come back to class with these 3 graphs, I'd have 3 different groups come up and put their graphs on the board. And they would label the turning point of the graph. With the function listed above it and the graph below it, that allowed me to jump right into a discussion of HK and how to translate your basic absolute value graph into this new translated graph. And it allowed us to get through a lot of that beginning material at home so that we could focus on the more advanced concepts of translations and shifts and so on. So it doesn't have to be video. It just has to be something that, in my opinion, that can get your students to do a little thinking on their own. Lead them along the way, but then give them some point in the problem, like problem 3 here, where they have to make a turn towards extending what they've done with some original thought. All right, let's get back to the slides briefly. So I'm just going to summarize my feelings on this, and then we're going to open it up to questions that have come in. I believe that true learning only occurs when students participate in the discovery of the procedures and the problem-solving strategies rather than being handed a recipe of steps to follow. I think that our classrooms have to be two-way streets. When all the communication is flowing in one direction, students have no ownership, they feel no connection to it. But when you're encouraging them to think in class, encouraging them to share, encouraging them to not be afraid to try something that may not work, that's part of the discovery process. You have to try something. If it doesn't work, try something else. It's a lot like playing a video game, right? When we try a strategy, if that's not a good strategy, find another one. But you have to be willing to try those things. And I think that encouraging your students to discover will lead to greater understanding, which will definitely lead to better results heading out. So to sum up, I've talked here at length about the discovery process, but you really want to incorporate it into your style of instruction. So for me, that's just have students discover, have them engage with me in class, and then at the very end, let's make sure we reflect on what we've learned so we can carry this forward to the next round. We'll open it up for questions now. I'll leave the feedback screen up. My email address is georgew@cos.edu, and you can find me on Twitter at George Woodbury.
Perfect. Well, the question and answer box lit up like wildfire when you were talking about the videos. And I think I got like 4 questions that are basically the same thing. Okay. So are you ready?
Okay.
I bet you've heard this question before. How do you deal with those students who don't watch the videos prior to coming to class? That kind of sums up the next 4 questions.
That's the #1 flip question, right? It's like, how do you know that, how do you make sure they do what they're supposed to do before they come back? And I do it in 2 ways. I do it, one, with some sort of a pressure, because in my classroom, students are working together. And if there's one thing that students don't want to do, it's let down their colleagues. So if I come in not ready to go, I'm just an anchor dragging my group down. So my group is not going to tolerate that for very long. So there's this implied social pressure to do it. But let's be honest, students don't really like to do optional things. And so there has to be some kind of grade attached to it. In my flipped classroom, I give my students through the online learning system that we use, the publisher system that we use, what's called a media assignment. So I tie together videos that they have to watch, and they get points for watching the videos, along with questions that are based on those videos. So there would be a video that shows how to add 2 numbers. And then there would be a question or 2 where they have to actually add 2 numbers. And then a video about subtracting 2 numbers, followed by a question. And so there's an assignment that goes into their grade book that expires the moment class starts. So if they haven't done it before class, their grade is going to suffer. And although we'd like our students to be motivated by, I'm going to do it because I want to learn as best as I can, sometimes we have to have some of those extrinsic motivators called grades, and that really does the trick for me.
Okay, so the follow-up question to that in that same batch was, what do you do? What if they don't do the work in advance? Like, do you have a reaction to that?
Well, if they don't do the work in advance, like I said, if they're working with other students, those students aren't going to work with them in the next round because, you know, and I say it out loud. I say, listen, I want you to work with people who you think you can work with. And I don't want you working with students that aren't coming back prepared. So if somebody has let you down in the past, don't feel like you need to continue working with the same people. You know, I had a student today, I mean, it's a great point. In my statistics class an hour ago, the student said, you know, I just don't understand what's going on. And so I asked, well, did you do the preparation assignment? And no, I didn't have time to do that. I said, well, like I said on day 1, that's how we're learning. You know, you have a choice. There are 2 ways to learn statistics. You can come to class and I can introduce you, and you can go home and try to make sense of it, or you can introduce yourself to it and I can help you make sense of it here inside the classroom. And that's the route that we picked. So if you're not going to hold up your end of the bargain, you know, the person that you need to be talking to is probably the person in the mirror, right?
Definitely. This is kind of along the same lines. A question came in about, you know, typical community college students don't have a lot of time, right? They're working, they've got family, they've got all kinds of obligations. How do you handle that situation?
Yeah, so I try to stagger the homework so that their first priority is the flipped assignment. So that's due before class begins. And those, for Chapter 6, the day we take the Chapter 5 test, those are all open. So I'm always encouraging my students to make the most of their time. And if they want to try to work ahead, they can. But the follow-up homework, so there's homework that follows the class session to make sure that they understand. That homework is staggered. Typically in my STAT class, it's due the following Monday. So whatever we cover this week, I want you focusing on the flip assignments first. The homework is due the following Monday. So they have a week to piece those parts together. I've also experimented with the idea of personalized homework. So my students in my elementary algebra class this semester, they complete a flip assignment before they come to class. We do some group problem solving in class. And then when they go home, they have the opportunity to take but they have to take a personalized, a reflect quiz where I've selected 4 or 5 of the problems that I think are most important for students moving forward. And if they get all 5 of those questions correctly, they have no homework. But if they get one of those questions incorrect, the system will provide them with personalized homework based just on that one type. And they'll get a few problems to try for each one that they miss. So if they're doing a lot of learning in class and they're understanding, their homework could be as simple as 5 problems each night. And that's pretty valuable too to them.
Yeah. So somebody also kind of chimed in with what you're saying about, there's a couple different ways to think about doing these things with respect to time. And that is that you can actually reduce the total number of problems and examples because you're immediately working on this. They're immediately making some connections. You're not going home. I think what she's saying is that you're not going home to learn it on your own at this point.
Right. Yeah, that's perfect.
Yeah, I think that's what she said. This person also spends less time reviewing before exams because of the depth, I'm assuming.
Definitely.
Finally, one of the main ideas of the flipped classroom is to move the lower level learning, the first or 2 or 3 levels out of Bloom's outside of the classroom, I think.
Right.
Yes.
Right. And so I do think that some people get a misconception of what flipped learning is in terms of students are going to teach themselves outside of the classroom and then they're just going to do more of the same inside the classroom. And that's not true. So as an example, in my statistics class, we have a pretty full course outline, but we don't cover non-parametric tests, things like that. But in my class, we do those as part of the flipped classroom day. So they've learned how to do, say, the one proportion test. And now I'm going to give them some problems that some of them they'll do with their standard Z test, and some they're going to use the binomial distribution to do. We're doing above and beyond, and you have to, it can't just be a worksheet full of problems. There's got to be a lot of discussion, open-ended problems. It's supposed to be a more fun experience, a more fun environment to be in too, not the same old, same old. It's really a chance to break the mold, I think.
Okay, anything else coming in? There is something in the question and answer box that I tried to copy to put in the chat and I didn't. So if you haven't looked in the question and answer box, this one is still open. It was a link to a Vimeo that talked about demonstrating how to generate good mathematical discourse in the classroom, trying to help with questions for the advanced students to make sure that the advanced students don't answer all the questions.
Oh, very nice. Thanks for sharing that.
Yeah, another question came in. It says, how long before students seem comfortable with your flipped model?
You know, the first couple of days, they're a little anxious about it. But I think, especially at the developmental level, these are students that haven't experienced a lot of success mathematically. And it's all about getting them to that point where they experience that first success and they realize that, you know what, I can do this. Because, you know, they've heard all the messages. They're constantly thinking that, you know, I can't do it and it's okay because no one else can do it and nobody likes it, right? And
right.
So, like, this flipped experience gives them a chance working with other people to realize that, hey, you know, this girl right here, she's just like me and she's explaining how to do this problem. And you know what? I had an idea about how to do that one all on my own. And I'm having, you know, these initial successes. You've got to get them to that first batch of successes, and then it becomes pretty friendly. I think students knowing the idea that I'm going to watch some videos and do some problems beforehand, I'm going to have an engaging hour instead of a boring hour sitting there wondering why I'm here. And then maybe I'm not going to have quite as much homework on the other side. I think that's pretty motivating to them. And the idea that, I think at its core, they understand that concept of, if you introduce yourself, I can tailor the activities to help you understand the material. They're willing to buy in on that. So that gets them through a little of that initial anxiety as well.
Yeah, I'm going to extend that question, George. I'm going to put you on the spot. How
Okay.
long was it before you were comfortable with the flip method?
When it was hard, the first time I did it fully, I was off for a whole semester. I had a semester bank time, and all I did was prepare for this class, how I was going to run it, and it was pretty nerve-wracking. And the first day, I had my first success so early that it relaxed me. And then I went in, instead of, feeling like I was teaching this for the 40th time, I went in with my eyes wide open, like, I'm not sure what's going to happen today, but I'm ready for it, and it's going to be fun.
Right.
And, when you see that your students are learning and understanding big picture ideas, it's very, it's exciting. It really relit the spark for me. It's tough to do the same thing over and over and over again. And, we know that the students change from semester to semester, and, sometimes your emphasis changes, but here it's like every day is brand new and you never know. It's a lot of fun.
Yeah.
Scary fun, right?
Yeah. Yeah. All right. I don't see anything else coming in. I do have a little bit of AMATIC bookkeeping to take care of at the end here. You guys can still keep putting your questions in if you want to for George. Let's see. I got to grab the right window here. Okay. Thank you so much for participating in today's webinar. If you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC. We are on social media, Facebook and Twitter. George mentioned Twitter. That's where his name looked familiar to me before. I'd been following him on Twitter before I met him for this webinar. Recordings of the past AMATIC webinars can be found at bit.ly/AMATIC-webinars. And so it usually takes us about 2 weeks, 1 to 2 weeks to produce and upload the webinars to archive it and get it out there for you. This one probably won't take me as long. I don't think I have as much editing, knock on wood, as sometimes I normally do. If you'd please take 2 minutes to evaluate the webinar content and the presenter, bit.ly/AMATIC59, and I'll add that to the chat window here as well. You can't click on the screen like you could in Adobe. Make sure that you fill out this survey if you need the participation, the certificate that we print up and send to you. If you want one of those to prove that you are here today, please make sure that you fill out the survey.